Okay, and hello everyone. My name is Kuxin, and I am going to presenting our research on a pilot study of clinical AI collaboration in identifying a depression from speech. And I will start from discussing the connections between the speech and also depression, and then I am going to talk about our study, and finally I am going to talk about our findings. And previous research have found that depression can change the speech vowels in many ways. So the people who are having depression, they have changes in their phonological loop, and which could result in a change of their pronunciation of the vowels. And previous research have also found that people who have depression, they will often have a decreased frequency range on the vowel formants, and they may also have the shorter durations and also a less variance for the certain types of the vowels. So the goal of the study is to check that whether adding the model AI like explanations for the speech model is going to have like any impact on the trust and perceived usefulness, and also they perceived complexity. So the model used in the study is the one designed by us and has published in the previous paper. So we have the two key parts in the system. So the first part is the vowel model, or called encoder, and the second part is our depression classifier. So the system takes the group of speech utterance as input and converts them to the embeddings with vowel information, and then the final depression classifier provides a decision. So we are going to provide the various types of the model explanations, and the first one is the visualization of the spectrogram. And previous research have found that the spectrogram can be a good indicator of depression. So the people who have depression tend to have the darker color on their low energy parts, and also have the lighter color on the higher energy parts. And also it's more likely to lack the sustained energy between the frequencies, and such as a part being circled in the color green. So now we check the spectrogram of people who do not have depression, and we can see that the low energy part is less dark, and also the energy is more continuous. So we hope to highlight the part of the spectrogram that is relevant to depression. So the method we have used is called GradCam, and GradCam is a well-established method showing that which part of the input is most activated. And we hope this part contains the possible signs of depression. We also highlight that which utterance might be more important in the group of embeddings, and based on the depression classifier model. So here we show an image of our design interface page. So the user may choose different audios by choosing the patient ID, and they can also see the model output numbers or the probability of depression. And we have the transcripts in the color yellow, and we also have a plot and showing the contribution of every single utterance to the model's depression output, and which is obtained based on the GradCam combined with our depression model. And here at the bottom, we have two figures. So we have the raw spectrogram, and we also have the figure showing that which part of the spectrogram is most activated, to help people concentrating on the parts that might be more informative. So here we have the 4 different audio samples that we are going to use in the study. and they're coming from the DAC-OS data sets, and they have the different PHQ-8 scores, and which are the 3, 7, 12, and 16, and covering the different levels of depression. And we set the 3 types of conditions with different levels of AI, and we use a between subject design, and because we want to avoid any possible carryover effects. So the whole process is that after people are coming to the study, they first see a video and teaching them how to use the system, and also telling them the definitions of some technical concepts, and such as the definition of spectrogram. And then we have a set of the knowledge check questions to make sure that they know how to use the website, and we will answer their questions or provide corrections. And after that, they will open the web page and listen to the audio, and by the end of the listening, they are going to justify if the audio they have listened shows any signs of depression, and also answer the short questions relevant to the decision confidence and also trust. And after they have listened to all the 4 audios, they are going to complete a post survey, and which is relevant to trust and system usability, and also a website design. And finally, we have some open-ended questions to ask about their feedback. So here is the condition 1. We've already have audio and transcript and no AI. It basically serves as a control condition. So for condition 2, we have audio, transcript, and also the model's outputs, but we do not have any type of explanations. So for condition 3, we have everything as mentioned before. So we are presenting the findings we have for the first 10 participants. And they are all the female graduate students in the age of from 21 to 35. And most of them, they are majoring in clinical psychology. And we have the detailed information of every participant in the table. So we first report our quantitative findings, and since we have and because we have a very small sample size, we just average and compare the survey scores for the different conditions. And based on the SAS questionnaire, the condition 1, no AI, has a best usability overall. The main reason is because of its simplicity. And based on the question 2 to the question 4, and for the condition 3, it's harder to learn and more complex than the condition 2. But it's very interesting that based on question 1, people tend to use more frequently for condition 3, even it's harder to learn. Then we go to the survey for the trust, and since condition 1 does not have any AI, we do not measure trust for condition 1. And from the question 1 to the question 4, we found that people in condition 3 feel more trust than people in condition 2. But from the question 5 and 6, they say that people in condition 2 believe the system has a higher consistency and a higher likelihood of doing its best. And since the condition 2 does not have many components, it makes sense to have a higher consistency rating. Then we check the results of the website design. We found that based on the question 4, the transcript was very helpful for all the conditions. And based on the question 1, the condition 1 has the highest satisfactory score, and then followed by condition 3 and 2. And from question 5 and 6, we found that model probability output in condition 3 was less easy to understand than the condition 2, but was more useful. And we've also found that spectrogram was not easy to understand, but people think they are useful. So one possible reason for these ratings is that condition 3 has too many components, and these components are making the things harder to learn. But meanwhile, it also makes people have more trust and also feels more useful. And then we show the findings in the quantitative And we were able to code the interviews into the 4 themes. The first theme is a concern about the knowledge gap, and people have reported that more action should be done to solve such gap. And people have also reported that they hope to have more practice so they can have a better understanding of for the components on the web page. And the second theme is that people have actually have some constructive advice of how to build the AI model, and such as making the model more personalized and also making the model less biased. So the participants also say they hope to have a shorter decision window so if they solve a suspicious probability, they can check shorter audios. And the people have also suggested that we should consider some other contextual factors. Then the third theme is relevant to the human-AI collaboration, and the participants have mixed feelings. And sometimes they feel that the AI output can be counterintuitive, but other times they feel the AI can be a competent performer. They are not willing to use AI because AI is not in their education, but they would also like to try because it's a potential complementary role to the current diagnostic systems. And finally, they have mentioned some other possible usage, and such as training. So here we show some phrases from the participants. Since we are running out of time, so I will stop here, and please feel free to ask questions.
Thank you very much for being cognizant of the time. And is there any question from the audience?
So great presentation. Just one question, how your model is going to find and differentiate level of depression between a native English speaking person and a non-native person, because non-native people may have a different speaking style.
Yes, right. And since we have a very few data sets on that, so the model is training based on the one single data set, and all the testing samples, and they are from the testing set of that data set. So basically, right now, the different accent or the different languages is not a problem, but that will be a future work to testing the model on the more data sets.
Thanks for the very interesting presentation on acoustic analysis. And also wanted to ask about linguistic analysis. If you also include the linguistic analysis, the choice of words, etc., how much will that increase your accuracy? And also, can you compare with the the digital phenotyping methods that use smartphone, for example, tapping speed, and sociability and sleep, etc., as ways of diagnosing depression? Thanks.
Yes, right now, so the main reason of why we are already having the audio is that so the purpose of the system is to be designed to be combined with some other systems. So so by combining with other features, and that will making the whole thing way more complex. So yeah, and that will be a good part of the future work. But for now, we are just concentrating on the speech because it's already hard enough. So yeah.
All right. So I think we are running out of time. So let's thank the speaker once again.